Bismillahirrahmanirrahim. Today we are going to study average rates of change and secant line. The question is, what is the average speed of any body which is moving or maybe in rest? You can find the average speed of a body. So the definition is average speed is equal to change in position divided by change in time, or rate of change in position with respect to change in time. The formula to calculate the average speed is final position minus initial position divided by final time minus initial time. That is average speed of a moving body during a time interval. So maybe time interval is t0 to t1 is found by dividing the distance covered by the time elapsed. It means total time taken by that body. So example 1 is a rock breaks loose from the top of the tall cliff. What is the average speed if y is equal to 16 t square denotes the distance fallen in feet after t second. The first part is during the first 2 seconds of fall. It means y is equal to 16 basically is the distance. Y is equal to 16 t square. This one is a function, as we know that this one is a parabola. The distance given by a parabola and time interval is given as the first 2 seconds. It means when we have to, it means in terms of interval, when we have to write out this time in term of interval, what will be the interval? The movement, it means when the experiment start, the rock was at rest position and the experiment starts, so initial time is 0 and you have to calculate the average speed at first 2 seconds. It means when experiment start, time interval initial time is 0 and final time is 2. So this one is your time interval in case of part 1, and the distance is given by this formula y is equal to 16 t square. So according to the above definition, average speed is equal to change in displacement divided by change in distance divided by change in time. In this case, distance is denoted by y, so this one is delta y over delta t is equal to position or distance at what is the last time or final time is 2 and initial time is 0. So change in distance is basically, or change in position is basically position at final time, this one, and this one is the position at initial time divided by final time minus initial time. Final time is 2 and initial time is 0. So we have to calculate the functional value at 2 minus functional value at 0 divided by 2 minus 0. So put the value to calculate the initial value at 2. Final value at 2. You have to put the value 2 in this function y is equal to 16 t square. So place 2 at 2. So this one is 16 t square. So t value is 2 here, t 2 square minus, and for this one value t value is 0. So 16 0 square divided by 2 and simplify the answer, gives you the answer 32 feet per second. And now comes to the part B. During the first second interval between second 1 and second 2. Focus at the wording. The wording is first second, 1 second interval, basically 1 second interval between. He is telling you that length of the interval is 1 second between second 1 and second 2. It means experiment starts when time is 1 second and ends when time is 2 second. So that when you have to write the time in term of interval, so you will write 1 2 2. Again, note, focus. He is telling you during the 1 second interval. 1 second interval means total length is total length of time interval is 1, which is starting from second 1 to second 2. So initial time is 1 and final time is 2. And here the total length of the time interval is 2 minus 1 is 1 second, which is he is telling you in term of like saying 1 second time interval. So again we have to calculate the average speed. What is the average speed? Again we have to calculate the average speed given by the distance y is equal to 16 t square formula. Now initial time is 2 and final time is 2. Initial time is 1 and final time is 2. We will use this formula again. According to this formula, now we have to calculate y of 2 minus y of 1 divided by 2 minus 1. From the part B, from second 1 to second 2, delta y over delta t, this one is the average speed. 16 t square, this one is the final position, minus this one is the initial position, final time minus initial time. Solve this, simplify this by using calculator. This one is equal to 48 feet per second. Now generalize this concept. This one is the average speed of a moving body. It could be car, it could be any body, maybe a ball, maybe a bug moving. So generalize this concept. Given an arbitrary function y is equal to f of x, we calculate for any function y is equal to f of x. As we read many functions in chapter 1, y is equal to maybe linear function, y is equal to ax plus b, y is equal to e की power x, exponential function, or y is equal to sin x, maybe any trigonometric function. So generalize the concept for any function that you have read in chapter 1. We calculate average rate of change in y with respect to x. So y, here y is a function of x. Y is dependent and x is independent variable. Y is depending on x. So whenever you have to calculate the rate of change in dependent variable with respect to independent variable, you have to calculate the rate of change in y with respect to rate of change in x. It means change in y divided by length of interval over which change occurs. Length of interval of x over which change occurs. It means f of x2 minus f of x1 divided by x2 minus x1. This is the same concept as we have calculated earlier for average speed. Final position minus initial position divided by final time minus initial time. So generalize the concept. Definition: the average rate of change of y with respect to x over the interval x1 x2 is delta y over delta x is equal to f of x2 minus f of x1 x2 minus x1. Geometrically consider any curve. This one is a curve y is equal to f of. The same concept we are going to relate this with graphical point of view. As in calculus, we have to calculate each and everything with respect to graphical point of view. So this one is any arbitrary curve y is equal to f of x. Choose any point. Let's say this one is the initial point. This one is a point P. Draw a perpendicular on. This one is your x-axis and this one is the y-axis. And point 1 is, let's say this point is x1, and according to this functional value is f of x1. So the point is x1, f of x1, y value is f of x1. And consider any neighboring point q. Let's say point q is here. Again draw a perpendicular on x-axis x2, and according to this functional value f of x1 is basically the length of this part, and f of x2 is length from parallel to y-axis, from x-axis to part this f of x2. This one is f of x2. Match these lines, point P and Q. What is the name of this line? This line is called secant line. What is the secant line? Secant line is any line which cut the graph or which cut the curve at 2 points of the curve. That is called secant line. This line cut the graph. Which one is the graph? Y is equal to line showing by the black line is the graph. Cut the graph or cut the curve at 2 point is P and point Q. Write it in term of like coordinates x2, and this one is coordinates of point Q are the x2 and f of x2. So we are going to relate this definition in term of graphical point of view. So what is the average rate of change in any y with respect to x or with respect to independent variable? What is called this line? Okay, so this one is f of x2 minus f. So this distance is f of x2 x1, and this distance is x2. So what is the difference between x2 or x1? This one is the difference between x1 to x2. Let's say this one is denoted by h. So write x2 in term of x1. What will be the x2 is equal to x1 plus h. This one is x1 and this one is h. So total x2 is equal to x1 plus h is equal gives you x2. Or when we have to write the h in term of x2 minus x1, like h is equal to x2 minus x1. So basically h is the distance between x1 and x2. So f of x2 minus f of x1, we rewrite this definition in term of h variable. x2 now is equal to x1 plus h. So f of x2 is equal to f of x1 plus h minus f of x1, and x2 minus x1 is equal to h. So the formula becomes, so this one is the average rate. So average rate of change is equal to f of x1 plus h minus f of x1 over h. So what is this according to the graphical point of view, or what is the geometrical meaning of average rate of change? So now we are going to study are going to understand the geometrical meaning of average rate of change of f of x over x1 x2. This one is the slope of line joining point P1 f of x1 and Q x2 f of x2. So slope of the line. What is the slope of the line? He is talking about this line. This is a secant line. Slope of this line. What is the slope of this line? Slope of any line. Before we are going to study or relate the slope of this line, we will recall the concept. Slope of line. What is the slope of line? Any line. Let's say this one is the line. So slope of line is, draw the perpendicular. This one is rise over run. Perpendicular distance divided by horizontal distance. Slope of line is equal to rise over run. So, the slope of this line will be equal to, now draw the, in this case, slope of this line or this secant line is perpendicular distance is equal to this part and horizontal distance is equal to this part. Horizontal term distance we already denoted as h, and what is the perpendicular distance or rise? Rise of this line is this much distance and run of this line is h. So if we have to calculate this part we will donate in term of f of x2 and f of, how we can calculate? Total distance is f of x2 and distance from x-axis to this part is f of x1. So this part is equal to total distance minus this part gives you this, which is equal to f of x2 minus f of x1. So now this part becomes the rise and this part is h is the run, which is the slope of line PQ. So rate of change of f of x over x1 x2 is equal to slope of the line joining P and point Q, or in other word this one is a line, secant line. Why? Secant line is a point which touch the graph or curve at 2 points. So this line is touching at point P and at point Q. Touch, or you can use the word cut, which the line which cut the curve at 2 points. So you can say that rate of change is basically the slope of the line joining P and Q, or you can say slope of the secant line passing through point P and Q. So come to the exercise part. Find the average rate of change of the function over the given interval r of theta. For first part is r of theta is equal to 4 theta plus 1. 0 time interval is, sorry, in this case this one is not the time interval. Here the dependent variable is r and independent variable is theta. So according to theta, this one is the theta value. Theta belongs to 0 to 2 and theta, so theta is the 0 is the initial value of theta and 2 is the final value of theta, and r of theta is equal to is defined through integration square root of 4 theta plus 1. So the part 1 is we have to calculate the average rate of r theta. What is the average rate of r theta? Delta r over delta theta. Final r minus initial r divided by final theta minus initial theta. So r of 2 minus r of 0. This one is the functional value of r at 2. How we calculate the functional value of r at 2? Simply we have to put the value of 2 in theta in given formula in which through r is defined. So 4 of 2 plus 1 square root, and r of 0 is simply place 0 where is the theta in the formula. 0, put this value 4, 0 plus 1 gives you this. Divided by 2 minus 0 is 2. So is equal to 3 minus 1 over 2. Simplify this values. 4 into 2 8 plus 1 square root 9. Square root 9 is 3 and this one is 0. 0 square root of 1 is 1. So 3 minus 1 over 2 is 2 by 2, and which gives you 1. So this one is a average rate of change of r. Or the same question he can ask, he is asking find the average rate of change, or we can, or I can also ask you in exam, find the slope of secant line passing through theta 0 and theta is equal to 2. Now comes to the part B. Find the average, the same question, average rate of change of the function over the given interval p of theta is equal to 2 plus cos of t. In this term, p is defined through t. What is the t value? T belongs to minus pi to pi. So initial value of t is minus pi and final value is pi. This one is the t, not theta. So what is the average rate of change in p? Average rate of change in p with respect to t is p of pi minus p of minus pi divided by t value is pi minus pi. Solved here. P of pi minus p of minus pi divided by pi minus pi. We will write it here. Delta p over delta t. So how we calculate the p of pi? Again, replace pi where t comes in the formula, wherever. 2 plus cos pi minus 2 plus cos minus pi. Cos pi is minus 1. So 2 plus minus 1, and this one is also cos of minus pi is also minus 1. So 2 minus 1 minus 2 minus 1 gives you 0 divided by 2 pi is equal to 0.